Okay, this video is on binomial expansions. I'm just going to look at the year 12 binomial expansions, which is to a positive integer. So just to clarify what a binomial expansion is, a binomial expansion is expanding the brackets of the sum of two things. Okay, I'm going to just call it a plus b in this general case, and then that's all to the power n. The general binomial expansion, this n can be any number, but as I said in today's video, we're just going to look at n as being a positive integer, and that's on the year 12 course, so to expand these brackets. Now you can expand those brackets if n is a positive integer manually, but this technique will make the process much quicker, because it can be quite laborious, especially if n is something like 15, which it can certainly get to. Okay, so n is specifically a positive integer for this video. Okay, so let's have a look at an example. So here we have one example. It just says expand fully 2 plus x cubed, and I'm just going to go through this one quite slowly and explain exactly kind of the shortcut method that we are going to be deriving. So 2 plus x cubed, well, what that means is it's 2 plus x times 2 plus x times 2 plus x. Okay, so what we're doing is we're multiplying all this together, and for each term in this expansion, you are taking an item from the first bracket, timesing it by an item from the second bracket, and then timesing it by an item from the third bracket. So altogether you've got 3 items. So I could take the 2, the 2, the 2, or I could take the 2, the 2, the x, or perhaps the 2, the x, the 2, or the x, the 2, the 2, the 2. And hopefully you can start to appreciate where the combinations come from, which we looked at last video. Okay, what I'm doing here is I'm choosing R items from n. In this case, I'm going to be choosing R2s, perhaps, from the 3 brackets I've got. So 2, 2, 2, so that's 2 cubed. If I'm going to choose the 2s, there's only one way to do it. Okay, 2 cubed. I've got to choose the 2 from the first bracket, the 2 from the second bracket, and the 2 from the third bracket. There's no other way to get some 2s in there, or just 2s. So there's only one way to do it. What about if I take 2 2s and an x? Well, I could take this 2, and this x. That's one way to do it. But I could take this 2, and this x. That's a second way to do it. And actually there's a third way as well, because I could take the 2 2s from the second brackets and then take the x from the first bracket. So there's 3 ways to choose 2 2s and 1 x. And the way we would notate that is n, so 3 altogether, choose 1 or 2. Call it 2, doesn't really matter. So I'm choosing 2 2s from the 3 2s I've got available. So there's 3 ways to do it. Okay, I could repeat the same process for choosing 1 2. So I could choose the 2 from the first bracket, or the 2 from the second bracket, or the 2 from the third bracket. So there are 3 choose 1 ways to choose 1 2. So that's 1 2, and that's going to leave me then with 2 x's. Okay, so if I'm choosing a 2 from this bracket, I have to choose the x and the x from the other 2 brackets. Or if I choose the 2 from that bracket, then I'm choosing the x from the first bracket and the third bracket, and so on. You'll notice that at each stage, I've got 3 items. There's 3 2s, there's 2 2s and 1 x, there's 1 2 and 2 x's, and then for the final term, we're going to have 3 x's. And just like the way of choosing 3 2s, there's only one way to do that, and that is to choose the x from the first bracket, the x from the second bracket, and the x from the third bracket. If you like, what you could do to complete the pattern here is I could say that's 3 choose 3. Okay, that's how many ways there are of choosing 3 2s from 3 2s. And over here, I could put in the coefficient 3 choose 0. That's the number of ways of choosing 0 2s from the 3 2s I have. But if you think of Pascal's triangle, which is exactly what these binomial coefficients come from, okay, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, that's the row I want, we can see that 3, let's do this in the right colours, 3C3 is 1, 3C2 is 3. 3C1 is also 3. And 3C0 is 1. So you could omit the first and the last term. So 2 cubed, well, that's 8. Plus 3 times 4, so that's going to be plus 12x. Okay, so 3C2 is 3, see that in green over here. And 2 squared is 4, so you get 3 times 4, which is 12. Here we're going to get 3 times 2. Okay, 3 is the binomial coefficient circled in red, times the 1, 2 we have, so that's going to be plus 6, and that's times x squared. And then finally the last term, 3C0, which is 1, as ringed in blue, plus x cubed, which is plus x cubed. Okay, so I said I was going to go through that quite slowly. That's just to explain exactly how we get to this. Once you get proficient in the binomial expansion, you can jump from this line to this line. Okay, you don't have to be faffing around with all these binomial coefficients. You just need to work them in your calculations. If you're unconfident, I do recommend you do write down this step as well, just to make sure you get the method marks. Okay. All right, so example, as I would actually do it perhaps in an examination setting. This one says expand fully. Not all questions will say expand fully. Some will say find the first so and so terms. This one says expand fully, and expand fully means all terms. So this is to the power 5, so there's going to be 6 terms altogether, because you've got the x to the power 5, the x to the power 4 term, 3, 2, 1, and then the constant term as well. So it goes from x to the n all the way down to x to the 0. So 6 terms. Okay, so what we're going to do is we're going to say, let's take 2x, and I'm going to raise that to the power 5. Okay, that's the first term. Plus 5c1, okay, that's the number of ways of doing this, 2x to the power 4 minus 1 to the power 1. Okay, so that's the number of ways of choosing it. And I'm choosing 4 2x's and 1 minus 1. Okay, so off the 5 brackets, I'm choosing 4 of the 2x's and 1 minus 1. Notice there's still 5 items in there. Okay, there'll always be 5 items in each term. Plus 5c2, 2x cubed, minus 1 squared. Again, this is the number of ways of choosing 2 items from 5. Okay, so in this case, I'm choosing 2 minus 1s. And there's 5 minus 1s altogether. So that's going to be 2x all cubed. So that's 3 of the 2x's and 2 of the minus 1s. The next term, 5c3, 2x squared minus 1 cubed, plus 5c4, 2x to the 1, minus 1 to the 4, and then finally 5c5, which is just 1, minus 1 to the 5. And that completes the expansion, and we can see all 6 terms in there. But just notice the pattern. I've got 1, 5c1, 5c2, 5c3, 5c4, and then back to 1 again, which is 5c5. So the binomial coefficients just, the R value goes up by 1 each time. There's always 5 items altogether. So here I've got 5 2x's, here I've got 4 2x's and a minus 1, 3 2x's and 2 minus 1s, 2 2x's and 3 minus 1s, 1 2x and 4 minus 1s, and 5 minus 1s. So in each term, there are 5 items, because I have to choose 1 item from each of the 5 brackets. So the last step now to do is just to simplify all of these terms. Okay, we're looking for a number times the power of x. Okay, so 2 to the power of 5 is 32, x to the 5. Don't forget that if you're doing 2x to the power of 5 affects the 2 as well, not just the x. So 2 to the power of 5 is 32, and then x to the 5 is x to the 5. Here, that's going to be the number 5. Number 5 times 16 is 80. And then we've got minus 1, which is just minus 1. So it's minus 80 x to the 4. 5c2, again, you can either think of Pascal's triangle, or perhaps you can use the NCR formula, which I gave in the previous video. Either way, you get that 5c2 is the number 10. 2 cubed is 8, and then minus 1 squared is positive 1. So we're going to get an 80 again, but this time it's positive 80. And then this one here, 5c3, again, using the formula or Pascal's triangle, arrive at the fact that that is the number 10. 2 squared is 4, times minus 1 cubed, but minus 1 cubed is minus 1, so it's going to be negative 40x squared. This one, 5c4 is 5 times 2 is 10, so that's going to be 10x to the 1. And then minus 1 to the 5, well, that's just minus 1. And this line here, that is then the full binomial expansion, which is your answer. Okay. One final example before we finish. This one is just for a select number of terms, not all of the terms of the expansion. So find in ascending powers of x the first 4 terms in the expansion of 3 plus 0.5x to the 6. Okay, so we're looking for ascending powers of x, so we must start with x to the 0. So that is going to be the 3 to the power 6 term. Okay, that's x to the 0. X to the 1 term, well, there's going to be 6 C1 ways of doing it. It's going to be times 3 to the 5 and 0.5x to the 1. Okay, so I'm choosing 1 0.5x and 5 3s. And there's 6 choose 1 ways of doing that. Plus 6c2, 3 to the 4, 0.5x squared. Plus 6c3, 3 cubed, 0.5x cubed. And that's the first 4 terms. That's all I'm asked for, the first 4 terms. So we've got an x to the 0, an x to the 1, an x squared, and an x cubed term. And that is the first 4 terms. Get the calculator out and do 3 to the power 6. That's not something you need to necessarily know. So that's 729. 6 choose 1 is 6. Again, either Pascal's triangle or NCR formula will tell you that. 3 to the power 5 is 243. And then, of course, you've got to times it by a half because the 1's got to come into effect there. So essentially, it's 3 times 243, which again is 729. So the coefficient of x is also 729. 6 choose 2. Now, on your calculator, you can calculate this. It will tell you. Essentially, it's going to be 6 factorial. Show you how I do it under here. It's going to be 6 factorial divided by 2 factorial, 4 factorial. And that's the formula method. So that's 6 times 5 times 4 factorial divided by 2 times 4 factorial. And I've written the 6 factorial like this, which is obviously the same thing, okay? Because then the 4 factorials will cancel, and I'm left with 3 times 5, which is 15. Or you can go down to Pascal's triangle, or you can type in 6 choose 2 on the calculator. That also works. Either way, that's the number 15. 3 to the power 4 is 9 squared, which is 81. And then we've got 0.5 squared, so that's a quarter. So we're going to have 15 times 81 times 0.25. So that's going to come out to be 303.75 x squared. And then finally, 6 choose 3. Again, you can run through with the factorial formula. Just 3 factorial on the bottom. So that's going to be 6 times 5 times 4 times 3 factorial divided by 3 factorial, 3 factorial. So that will cancel with that. That is 6, so that will cancel with that. We're left with 5 times 4, which is 20. So 6 choose 3 is 20. 3 cubed is 27. And then 0.5 cubed, well, that's an eighth. So we're going to have 20 times 27 times 0.125, which is an eighth. And that gives us plus 67.5 x cubed. And that is the first 4 terms of this expansion. Okay, so that's the answer. That's what the question asked for. just the first 4 terms. Okay. Thank you for watching. Hopefully you found that useful. Drop some comments if you're unsure of anything.